Hi, so now we are in the chapter 2, the system unit in CSC134. Okay, so let us start. Uh, okay, the learning objective LO is you can differentiate between the five basic type of system unit. Describe system board including socket, slots, and bus lines. Recognize different microprocessor including microprocessor chips and specialty processors. Compare the different type of computer memory including RAM, ROM, and flash memory. Explain expansion slot and cards. Describe bus lines, bus width, and expansion buses. Describe ports including standard and specialized ports. Identify power supplies for desktop, laptop, tablet, and mobile device, and also explain how a computer can represent numbers and encode characters electronically. Okay, so for the introduction, as we know that speed, capacity, and flexibility determine the power of personal computer. As you know, the speed, capability, and flexibility is more to determine the power of your personal computer. Knowledge of a computer's power allows you to make good buying decision and to determine if your current system will run new applications. Competent end user need to understand the functionality of the basic components of the system unit. Okay, what is system unit? As we know, system chassis is a container that house most of the electronic components that make up a computer system. It's a system chassis. So system unit, it contains systems, electronic components, and selected secondary storage devices. Okay, system unit types. We have several system unit types. We have a desktop, laptop. Okay, the desktop system unit is in a separate case. Tower unit, we have a tower unit as you can see here. Okay, all in ones, that's all components including monitor. Okay, for the laptop, we have a portable and much smaller than desktop. Okay, we have ultrabooks, that is a laptop and tablet in one. So this is the example of ultrabooks. And we also have a laptop for gaming that have a high-end graphics. Okay, we also have tablets. Okay, we have a mini tablets. Okay, we have a smartphone that is most popular device, handheld computer. We can call it a computer that we can uh, post or we can hold with our hand. Okay, and extend the capabilities of cell phone. Okay, there is a smartphone. There is a differences between smartphone and cell phone. As you know, previously, in the we can say in the old time, we also have a cell phone, but it's not a smartphone. It's just can receive a text. It can we can do a call, and the function is very limited. But in the smartphone, we have a lot of things that we can do. We can have a camera in it. We can install Waze and we to find the direction. We can have calculator. We can have a lot of things. Okay, calendar and so on. That's why we call it as a smartphone. Okay, and also number 5 is wearables. That's contain embed computer. Wearables is something like this watch. Okay, so we can wear the smartwatch. So there are a lot of smartwatch uh, in the market nowadays. So I believe that most of you also know about wearables. Okay, so the components. Okay, what is component? Although Although all devices come in a many shape and size, they have similarities such as system board, microprocessor, and also memory. Okay, so how to assemble and disassemble a system unit? Okay, so you have to know how to assemble and also disassemble a system unit. Okay, for example, here is a desktop. Okay, you can see here is a desktop. Okay, this is the laptop. Okay, so this is a tablet. Okay, this is a smartphone, and this is a wearables. Okay, maybe we can say as a smartwatch. Okay, system board or main board or motherboard controls communication for the entire computer system. All components and devices connect to the system board. So as you can see here, this is the motherboard. It's control the communication for the entire computer system. All components and devices connect to the system board. Data parts and traffic monitor also reside in the system board. Okay, it allows various components to communications efficiently with one another. Okay, so socket and chip. What is socket and chip? Okay, the system board contains a variety of electronic components such as socket and chip. So what is socket? It's the connection point for chip. We call it as a socket. Okay, so what is chips? Chip is a tiny circuit board etched onto squares of silicon, also called silicon chip, semiconductor or integrated circuit, mount on chip carriers. So this is a socket, okay, and this is a chip. So you can see it's very small, okay. Slot and bus line, additional system board components. Okay, we have a slot and we have a bus line. What is slot? Slot provide a connection point for specialized card or circuit board. Okay, and it's provide expansion capabilities for the computer. Bus line, connecting lines that provide pathway to support communication among electronic components. Microprocessor is a CPU. Okay, we call it as a central processing unit or processor. Okay, that in the CPU contain on a single chip called microprocessor. Uh, Microprocessor is the brains of the computer. Okay, so two basics component of the CPU, we have a control unit and we have a ALU, arithmetic logic unit. What is control unit? As you can see, control unit tells the computer system how to carry out a program's instruction. Arithmetic logic unit, it perform arithmetic and logical operation. Relationship between memory, processors, storage, input and output devices. Okay, so you can see when the user starts a program, its instruction transfer from a storage device to memory. Firstly, the instruction transfer from a storage device to memory. And then data needed by programs enters memory from either an input device or a storage device. The control unit interprets and execute instruction in memory, and the ALU, arithmetic logic units, perform calculation on the data in memory. Resulting information is stored in memory, from which it can be sent to an output device or a storage device for future access as needed. So as you can see here, okay, so instructions transfer from storage device to memory. Okay, from storage device, okay, we transfer to memory. Okay, so we have an input device here, will input the data, and the memory will give an information to the output device. Okay, So memory also control the processor between a control unit and ALU. It will give instruction to memory to processor. Processor will process and it will pass back to memory and it will give an information to output device. Okay, processor machine cycle. For every instruction, a processor repeats a set of 4 basic operations which comprise a machine cycle. Okay. Step 1, it fetch, decode, execute, and store. So this is the 4 basic operation. For step 1, the control unit fetch the mat problems instruction and data from memory because of student enter a mat problem into the memory of the computer, and then the control unit decodes the mat problems instruction and send the instruction and data to the ALU. Okay, and then uh, step 3, the ALU perform calculation on the data. Okay, and then step 4, the result of the mat problem are stored in memory and the results in memory appear on the screen of the monitor. So step 1 is a fetch. Okay, then we go to this is from input. We go to control unit. It will decode, and then in control unit it will decode, and then it will execute by ALU, arithmetic logic unit. Okay, and then it will store in memory and display in the output device. Okay, so this is the step in the machine cycle. Microprocessor chips. Chips capacities are expressed in word size. Word is the number of bits that can be processed at one time. We have a 16 bit, 32 bit, or 64 bits. Okay, so for the clock speed, what is clock speed? Is processing speed or the number of times the CPU fetch and process data or instructions in a second. It, it's also called clock rate. It is measured in gigahertz or billions of bits per second. The faster the clock speed, the faster the computer can process information and execute instruction. So this is a clock speed. Okay, multi-core chips. Okay, multi-core processor is a two or more separate and independent CPUs within a system unit. So we have a quad-core supports 4-core processors. Nowadays we have a lot of multi-processor. Okay, multi-core processor. We have a quad-core. We have a lot of things. Okay, and then parallel processing, computers' ability to divide tasks into parts that can be distributed across each core. Windows 8 and Mac OS X support parallel processing. So as you can see here, we have a processor A series. Okay, we have a processor i7 and etc. etc. Okay, coprocessors designed to improve specific computing operations. Graphic processing unit, or we call it as a GPU. Graphic coprocessors. This is the specialty processors designed to handle a variety of specialized tasks, okay, such as the 3D image, encrypting data, and also standard features in gaming computers. Memory. What is memory? As you can see, memory can hold. It's a holding area for data, instruction, and information. It contained on chip chips connected to the system board store three basic categories of items. Okay, so the operating system and other system software, application program, and also data being processed and the resulting information. Three well-known types of memory chip. We have a RAM, ROM, and flash memory. What is RAM? RAM is random access memory. What is ROM? Read-only memory, and also flash memory. The system unit contains two types of memory. There is volatile memory and non-volatile memory. So for the volatile memory, loss it contains when power is turned off. Example includes RAM, cache memory, and virtual. So for the non-volatile memory, it does not lose contents when power is removed. For example, it's a ROM and flash memory. So RAM, what is RAM? Random access memory. Okay, it's a chip that holds programs and data that the CPU is presently processing. It can be a volatile or temporary. When the RAM is volatile or temporary, so the contents are lost when computer is powered off. Okay. Cache memory. So as you can see, it's a temporary high-speed holding area between the memory and CPU. Okay, it's an additional RAM can be added using an expansion module called a DIMM, Dual Inline Memory Module, DIMM. Okay, so as you can see here, this is a CPU. Okay, we have a L2 cache, and then this is a memory. So this is a chip. This is a circuit board. So you can see here is a dual inline memory module and also memory chip, and we have a memory slot here. Okay, virtual memory. What is virtual memory? A memory management capability that uses hardware and software to allow a computer to compensate for physical memory shortage by temporarily transferring data from random access memory to this storage. So virtual memory, this is a virtual memory. Yeah. Firstly, the data is in the RAM. If you less use of data, so the data will be transferred into a virtual memory. And then when the data is needed by the CPU, it will transfer back to the RAM. Okay. So each location in memory has an address. Memory is expressed in bytes. Okay. Memory size is measured in kilobytes, KB or K, megabytes, MB, gigabytes, GB or terabytes, TB. So as you can see, this is the term kilobyte. Kilobyte represent KB or K. Approximate number of byte is 1000. Exact number of byte is 1034. Approximate number of page of text is half. Megabytes MB 1 million. So as you can see here, gigabyte is 1 billion and terabyte is 1 trillion. ROM. What is ROM? It's a read-only memory. So all the information stored by the manufacturer is a non-volatile and cannot be changed. Okay. CPU can read or retrieve data and programs in ROM, but the computer cannot change ROM. Contain special instruction. For example, start the computer, access the memory, handle the keyboard input, and etc. Okay, flash memory combines of the features of RAM, can be updated, ROM is a non-volatile, Okay, and flash memory contains startup information. There is BIOS, basic input output system. Okay, the amount of RAM, flash memory also contains the amount of RAM and type of keyboard, mouse, and secondary storage device connected. Many ROM chips are being replaced by flash memory. Okay, so as you can see here and here, flash memory. Expansion slot and cards. Okay, the capabilities is to expand your system. Okay, we have a graphic cards for high quality 3D graphic. Network interface card, or we call it as a NIC. It connect device to network via cables. Wireless network cards is connect devices to network without cables, and also SD card, expansion card for mobile device. Okay, bus line, or we call it as a bus. So as we can see, the name is bus. So we go from one place to another place by bus. So the function is to connect part of the CPU to each other and various other components on the system board. It's a pathway for bits representing data and instruction. Bus width is a number of bits that can travel simultaneously down a bus. Architecture and design are tied to the speed and power for the computer. Two basic categories of buses. We have a system bus and also expansion bus. System bus connects CPU to memory. Expansion bus connects CPU to other components. So the principal types of expansion bus, we have a USB, universal serial bus. It connects external USB devices onto the USB bus. Okay, we have a firewire, primarily primarily used to connect audio and video equipment to the system board, and also PCI Express. Okay, or we call it PCIe. It's a single dedicated part for each connected device. Ports. What is ports? It's a socket for connecting external device to the system. Uh, port connects Ports connect directly to the system board and also to cards inserted into slots on the system board. We have a two type of port, that is standard port and also specialized port. So this is the type of port. Okay, so as you can see here, we know that this is for audio. Yeah, this is a cable TV. Okay, usually in our computer or in our laptop, we have a HDMI port, we have a serial port, we have a headphones keyboard. Keyboard is for uh, the desktop computer. Okay, okay, so this is the example of ports and USB, usually in our uh, notebook. Okay, so mostly you can found this port in the uh, desktop computer system. Okay, so as I mentioned earlier, see, this is the ports for PC, personal computer. We have a headphone port. Okay, and also microphone port. We have a keyboard port, we have a digital audio, a serial port, firewire port, USB port. Okay, we have a lot of port here. Okay, inside our PC. Okay, next, ports in our laptop. Okay, as you can see, this port is for more network. This is for modem. This is for USB. So I believe this is the example of the oldest version of laptop. So by the way, in the newest version, they reduce a lot of ports nowadays because some ports are not needed in the real life. So they just reduce it to reduce the price of the uh, notebook. Okay, standard port USB. We have a keyboard, mice, printers, storage device, Ethernet for high-speed networking, HDMI, high definition multimedia interface, Thunderbolt provide high-speed connection, can connect up to 7 separate devices through one port. Yeah, okay. So this is the standard port. Specialized port. Okay, we have external serial advanced technology attachment, or we call it eSATA. eSATA is a high-speed connection for external secondary storage. We have a MIDI, musical instrument digital interface that connect musical instrument. We have a mini DP or MDP mini display port that is a connection to large monitor. We have a VGA and DVI. It's a connection to analog and digital monitor. And also FireWire. So it's for high-speed connection to FireWire device. Cables used to connect external devices to the system unit via the ports. One end of the cable is attached to the device and the other end has a connector that is attached to a matching connector on the port. Okay, so it's a Thunderbolt. Thunderbolt is likely for the MacBook. Okay, this is the Ethernet. Okay, usually you can find it in other computer. Okay, personal computer. We have HDMI here. Okay, and then this is a USB. Making IT work for you. TV tuners. Okay, using Windows Media Center as a DVR, install TV tuner to connect your computer or cable to your computer. Okay, so power supply. Computer require direct current or DC power converting alternating current AC from walls, outlet or batteries. Desktop computer have a power supply unit in the system. Laptops use AC adapter in the system unit. Tablet and mobile devices use internal AC adapters, and smartphones can use wireless charging platform. Okay, as you can see here, this is the example. Okay, electronic data and instruction, digital electronic signal in one or two states, on or off, okay, recognized by computer. Analog signal is a continuous signal vary in strength and quality created by voice. Okay, conversion must take place from analog to digital before processing can occur. So this is the example analog signal and also digital signal. Okay, bit representation forming digital signal. Numeric representation two-step binary system consists of only two-digit call bits. On equals to 1, negative charge. Off equals to 0 or no charge. Byte have 8 bits grouped together as a unit. A byte represents a single character in the computer. Hexadecimal system use 16 digits to represent binary numbers. So as you can see here, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, A, B, C, D, E, F. It's a hexadecimal system. Okay, so for 8-bit byte for the number 4 001110100. 8-bit byte for the number 6 001101110. 8-bit byte for the letter E 01000101. So as you can see here, because of um, the uh, computer only can read in a binary number. Okay, so character encoding standards is a unique sequence of binary representation of a particular letter, number, or special character. It is used to facilitate communication among computers by using common language code. Okay, we have a ASCII, American Standard Code for Information Interchange, the most widely used coding scheme to represent data used by personal computer. We also have a EBCDIC, Standard Binary Coded Decimal Interchange Code, used by mainframe computer, and also we have a Unicode. There is new encoding due to explosion of the internet, use 16 bits and recognized by virtually all computer system. So this is for ASCII. Okay, okay, as you can see here, this is the binary number for the ASCII standard. A look to the future. Wearable computer send and receive email while jogging. As you can see now, it's not in the future. It's a nowadays. Okay. Maintain your personal schedule book. Remember the names of people at a party. So as you can see, a smartwatch can receive email. You also can know who called you. Okay. And also it can give maybe the calendar, timetable, and etc. etc. Okay, so the open-ended question, page 1 of 3, number 1, number 2, number 3. Okay, I need you to do it and submit to me in the Google Classroom. Okay, number 4, number 5, number 6, number 7, number 8, and number 9. Okay, that's all for today. Thank you so much. Bye.